welcome back to the Analyst Lens. So in this video we are going to understand about the logistic regression model, how we build a logistic regression model and how it works. So in the earlier videos we see how we build a simple linear regression model, a multiple linear regression model. So what is the difference between a simple linear regression model, multiple linear regression model and a logistic regression model? So basically in simple linear regression model we see that there are two variables, one dependent and one independent variable. So on the basis of independent variable we predict the dependent variable. Similar as in multiple linear regression, we build a model to predict the value of the dependent variable on the basis of multiple independent variable. So how it differs from a logistic regression model, let's see. So basically a simple definition of a logistic regression is that logistic regression is a statistical analysis method to predict a binary outcome such as yes or no based on a prior observation of a dataset. So basically in this logistic regression we conclude that about the categorical data. So categorical data, we can say that binary data also, where the outcome will be a binary or a boolean like yes, no, true, false, male, female, purchase or not purchase. So basically we use logistic regression where there is a categorical data or a binary data. So on the basis of dependent variable the outcome will be a binary outcome. So moving forward, a logistic regression model predicts a dependent data variable by analyzing the relationship between one or more existing independent variable. For example, a logistic regression model could be used to predict whether a politician candidate will win or lose an election, or whether a high school student will admitted or not to a particular college. These binary outcomes also straightforward decision between two alternatives. For example, if I take an example like जैसे कि एक स्टूडेंट है, उसके मार्क्स अच्छे आएंगे तो वो कॉलेज में एडमिशन लेगा. दिस विल बी अ सिंपल लीनियर रिग्रेशन मॉडल. सो in logistic regression model the independent variables like student marks in exam, student marks in competitive exam to qualify for the college. So these are the independent variables. So on the basis of this I want to predict the student will get into a college or not. So the dependent variable will be binary, like whether the student get into the college or student will not get into the college. So outcome will be yes or no. Moving forward, a logistic regression model can take into consideration multiple input criteria. In this case of college acceptance, the logistic function could consider factors such as students' grade point, average, set score. Set will be a examination to enter in the college, and a number of extracurricular activities. Based on the historical data about the earlier outcomes involving the same input criteria, it is then scores new cases on the probability of falling into one of two outcome categories. So now we are clear about the logistic regression. Basically here it differs from the simple linear regression and multiple linear regression because it has categorical or binary outcome. So here the outcome will be like binary, like yes, no, whether a student will get into admission into a college or he is not enrolled. So let's start the code part. So first we need to import the necessary libraries to build a logistic regression model. So first importing the libraries. So the first library will be pandas. So the panda is a sorting and indexing library for the data frames. So it will be a common library for all the analysis. The next will be Seaborn. So here we use Seaborn for visualization, like how the data are correlated with other variables. So the next will be So here we import two libraries, that is standard scaler and label encoder. So we will see further how we use it. So the label encoder is used to change the categorical data into a numeric data, and the standard scaler is used here to scale the data to avoid the extreme values and lower values. So basically it give the data a similar type. So here for the model building, we have imported two libraries, that is train test split. So for train test split, we all know that is used for splitting the data into the training and testing part, and for further building a model, we imported a logistic regression. Further we will import So here we imported a classification report. So basically a classification report is used to measure the quality of prediction from a classification algorithm. So it will help how to understand about the F1 score, the precision, the recall values and other. So let's import these libraries first. So as we can see that the command is successfully executed. So the next step will be importing the data, or we can say that loading a data. So for this we will just create a variable and store our data in this. The command will be like pd.read_csv. So I already copied the path for the file. You can just copy the file path and paste it here. So once we are done with loading the data, so the next step will data pre-processing. So in the data pre-processing part, we will just see is there any outliers in the data and just perform some sorting and indexing functions. So first will be like df.head to see the first 5 rows. So as we can see, there are total 5 columns, that are user ID, gender, age, estimated salary, purchase. So in the user ID we have these data, gender, age and salary. So we can see that the user ID is a column that we don't actually need it. So the other 4 columns are we needed, but the user ID is not needed. So we'll just drop the user ID column. So for this the command will be like df.drop columns, name of the column, that is user ID. We'll just paste it here and make sure the in place value will be true. So as we already know what it means when in place value is equal to true, so it means that the data is saved, it does not change anywhere. So let's see now. As we can see, we dropped that user ID and we only have columns that we needed. So for next step we can just check the any null values the data have, df dot. So we can say that we don't have any null values in each columns, like gender, age, estimated salary, purchase. We don't have any null values here. So for the next step we will just describe and get information about the data by this we can check the number of values we have in each columns, and we can also identify is there any null values by just typing command at df.info, and we can check the data type we have. like about the like age we have integer, and gender we have objects. So for predicting the a customer will purchase or not, for the purchase, for example, we have here the binary data for purchase. We have 0 and 1. So here the 0 represents that the customer purchased the things and customer does not purchase the things, and the 1 represents the customer purchase the things. So here we have a binary value, that is gender. So for converting, so first we will convert this value into a categorical data, like in the form of 0 1. So for doing this we will just first identify the x and y. So here the y will be our dependent variable, that is x, that because we know because we want to know whether the customer will purchase a thing or not. So for doing this we'll just create a variable that is y and store our dependent variable here. So for x the command will be like df dot drop columns is equal to purchase in place axis is equal to 1. So we can see here that the y will be the purchase column and the x will be our gender, age and estimated salary. So we can clearly see that the x are our independent variables on the basis of which we are going to predict the value of y, which is our purchase. So let's convert the categorical data into the numerical. So for doing this so here the categorical column is gender and we need to convert it to the numeric. So for doing this we will just use a label encoder library which we'll just imported earlier, like here. So the label encoder just convert the categorical data into a numeric data. So for this calling a library we just use le label encoder. So we execute this command successfully. So in order to change the type of that categorical data gender into a numeric data, we will just pass a command that is le dot fit underscore transform fit underscore transfer. Will just store it variable in the label and we just put it here the x, the gender column. Because we need to convert the gender into a numeric data, label encoder has no attribute fit underscore. Okay, so transform transform. So run this again. So as we can see that the command is successfully executed. So let's now check the label first. So as you can see that the data is successfully converted into a numerical data from categorical data. So here we can see that just by passing a command that is df dot head we can see that the male, the first, so here will be 1. So we just type it here for male it's 1, for female, and for female it is 0. So we successfully converted the categorical data into numeric data. The next step will be dropping the existing gender column and putting this label column here. So for doing this we'll just use df dot drop columns is equal to gender column here, and we will just put it in place is equal to true to save it. And let's see where the command is passed. So we can see here clearly that the gender column is deleted, and now we can just add our label part here as a gender column. For doing this we'll just use df gender. So we are adding a column in the existing dataset named gender and storing our label values here, so which is 1 for the male and 0 for the female. So we successfully executed this command. Let's see the result first. Dot head. As we can see that we have age, estimated salary, purchase and gender. So we can see that the gender is in the numeric column, like we have 1 for the male and 0 for the female. So we successfully converted the categorical data in the numerical data. So moving forward, the next step will be the training and testing part. So for splitting the data into training and testing. So by splitting the data into training and testing part, we'll just put that half of the data into the training, more than half of the data into the training part, and some part of the data in the testing part, so that we can predict the values. So see, we have done this, and we already imported the library for this, that is train, test and split. We also imported a library that is standard scaler. We will use the standard scaler here to scale the data first, because we have value like estimated salary that is 19,000, age that is 19. So we can't predict the values of the purchase by this data. We need to scale the data in the similar type. So for scaling the data, we will just store our standard scaler lib function in here. Successfully executed. Now we need to convert these column, that is age or estimated salary, or we can say that our so here it is. So we need to convert our x, or we can say that independent variable, into scaling part. So we'll just this by x ss dot fit underscore transform. We just use the same command as label encoder and put it here x. Could not convert male here, so it's showing some error here. Okay, so it's showing some error. So we just made a mistake, like we have to divide the data into x and y part after label encoder part. We just did it before the label encoder part. We will reconcile it by passing a command that is, which will be like x is equal to df dot drop columns is equal to purchase in place access is equal to 1. So now we just pass this command, showing some error, that is that is access. Okay, we just made a mistake here, like and we successfully executed this command. From here we need to remove this and put x here. Now we can see that the command is successfully executed. We just made a mistake, like we just put the independent variable in the x part before and label encoder part. So we need to put the data into the independent and variable dependent after converting the categorical data into numerical data. So please must ensure this. So as we successfully scale the data here into the x, so let's see x first. So as we can see that all the values are between the 0 to 1. So we just successfully scale the data. So the next step will be training and testing part. So for this we'll just type x train, x test, y train, y test, and use train test library here, train test split. And we have dependent and independent variable, so we just put it here. So x will be our independent and y will be our dependent variable, and test size will be, I will put 20% of the data in the testing part and the remaining 70% on the training part. And the important one, that is random state, will be 42. So here the random state basically are a part of this training and test split. So whenever I used to split the data, it will be in the 42 it will be on the 42 part. So basically whenever I run this command, it will give the same random state, that is 42 here. So just pass this command in here and successfully execute it. So our next step will be building a logistic regression model, that is logistic regression. So we did this. So now let's check this lr dot predict x and y. Okay, so we missed the command, that is fitting. So first we fit the data, lr dot fit x and y. So if we successfully fitted our model in the data, so must ensure this command first. So the next command will be predicting the values of x. So we just see that the values will be like this. So if I want to predict the value for a particular independent variable, we will just do this by predict. We'll just create a variable that is predict and store, pass a command that is lr dot predict For example, we have a female whose age will be 24 and his salary estimate will be 40. So it does not predict this value because it's a categorical data, so we need to convert it to the numeric data first. We'll do this by ss dot predict is equal to ss dot fit underscore transform, and this value here, method object is subscriptable, method of fit underscore transform, that is predict. Just need to remove this from here because we are predicting the existing value, and once we pass this command, this is successfully executed. So now let's predict, run this command first. As we can see here, it's showing 0. It means that the consumer will purchase the product. So for checking the score, we just pass a command that is lr.score. Okay, we need to know that is x and y. We can see that our model is 85% efficient to mark the product purchase yes or no. So basis, it means that our model is fitted best, that it is capable of identifying the correlation between the dependent and independent variable, on the basis of which it predicts the value of dependent variable on the basis of these independent variables. So for moving forward, for visualizing the relationship between the dependent and the independent variable, we will just plot a pair plot here by passing command that is sns dot pair plot, the data frame name, basically the variable in which we store our data, and here so actually we store our independent variable which we want to predict. So here the dependent variable is purchased. So as we can see, there are different charts are here, on the basis of which we can see that the correlation between the dependent and the independent variable here. As we can see here, the relation between the dependent and independent variables. You can use these charts to visualize the data, on the basis of which you can find the correlation between the data. So in the next step, we will just print a classification report which will help you to identify the relations. Classification underscore report, that is y, and lr dot predict x. Okay, lr classification. Okay, so as we can see here, these are the values of the precision, recall, F1 score, and the support. So basically here the precision means that how the accuracy of a positive prediction, for example, how efficient our model is, it is to predict whether the person will purchase or whether the person will not purchase. Here the recall value, basically we use here to identify the percentage of the positive cases. There the F1 score will be represent that how positive predictions were correct. Basically it means that how efficient we are to predicting the right values, whether the person will purchase the product or not, on the basis of the independent variable. So this is all about the logistic regression. So in this video we build a model, see how to scale the data by the standard scaler and how to convert the categorical data into the numerical data by label encoder, understand how to fit and transform the data existing, and here we see more about the multiple independent variable to predict the dependent variable that is binary in nature. And this is all about the logistic regression. We will see further in the next videos. Thank you, and please like and subscribe the channel.